What we do in life echoes in eternity.
Welcome. So I usually start my day surfing some YouTube educational videos to get my mind ticking. And this morning I watched a video on Markov-chain probability theory because honestly it was titled, "Can a simple math equation predict the future?" And as I watched this video, one simple question kept reoccurring in my mind, and I knew that I had to take care of it or I wouldn't be able to think about anything else throughout my day. And that question was, can a simple Markov chain plus a dash of quantum-inspired inference help organize the stock market noise? And in this short demo, I'll show a research tool that I created that does exactly that. So welcome to the quantum-inspired Markov chain backtester. Now, side note, this app is purely educational and not financial advice, kids, ladies and gentlemen, and everyone else. So now, let's discuss the logic and how the tool works, then we'll get into a quick demo. And at a high level, we created a machine learning market prediction engine. This engine uses historical data combined with machine learning, the Markov probability state modeling, and quantum wave theory to create predictions every day over historical data. We analyze its predictions and simulate that it was making trades based on the predictions for specified tickers. You could run this training indefinitely, and the theory is the self-reinforced learning loop will increase the accuracy of the predictions the longer it runs. So let's talk about how we organize that data and how we implement the Markov probability theory and quantum-inspired wave equations to predict the next day probability. At a glance, we turn each day's return into a discrete bucket or state. We learn how often the market moves from one state to the next. We then sharpen the next state probabilities with a wave-like refinement step that's inspired by quantum ideas. We combine those probabilities with a simple market context in a small model to make the next day predictions, and we size positions to target a steady level of risk. We then evaluate everything in a walk-forward manner, and we refit as we go. And so first, we bucket daily returns into a fixed number of states such as big up, flat, small down, and big down. We estimate how frequently the market transitions from each state to every other state, and then from today's state, we read off the probability of landing in each state tomorrow. And we then convert that probability view into an expected return using the average return seen in each state. And then second, we add a quantum-inspired layer that treats these probabilities like waves. We create a balanced version of the transition map so the process behaves nicely. We apply a wave evolution step that preserves the total probability but allows for some inference. And recent momentum sets up a phase that can amplify clear patterns and dampen noise. And after a few steps, we get a refined probability view and a sharper expected return. This tends to reduce indecision when the raw probabilities are spread out. And third, we build features from both views and from market context. This includes the Markov expected return, the quantum refined expected return, a confidence measure, a divergence between the two views, a momentum reading, recent volatility, and a drawdown signal. A calibrated classifier turns these features into a probability that the next day is up, and a simple ridge model blends the key signals into a single predicted return. Position sizing targets a consistent daily volatility so that the risk stays controlled. A small probability gate avoids trades that contradict the model's direction, and transaction costs are modeled as a simple charge each time the position changes. All results are predicted and refitted as time advances to avoid peeking into the future. Why this design? Well, Markov chains offer a transparent, easy to audit baseline. The quantum-inspired step preserves the probability while letting clear patterns stand out and noisy ones cancel. A lightweight meta model adds flexibility without requiring a large neural network, and volatility targeting keeps risk consistent, and a walk-forward testing reduces the look-ahead bias. Randomized search in the trainer isn't a practical way to explore a messy parameter space. Now, let's get into the demo, and then we'll come back to it. Welcome to the demo. First, we're going to talk a little bit about what's on the screen. We'll talk about the settings you can set, how to use it, what it's currently doing, and the planned future for it. And if you have any questions, please comment below or reach out to grant@zucalgroup.com. And so first we see in the middle of the screen here, we have the model overview and math. And the idea was we discretize daily returns into states, learn Markov chain over states, and use a quantum-inspired inference layer to refine the next state probabilities. We then feed those probabilities in context into a small ML stack to predict the next day return. Positions are volatility target, and all training is walk forward, refit, and predict the next day. First, we have the Markov chain return states, and it really just shows you the equations it uses to calculate those, as well as the quantum-inspired refinement with the equation that it's using to calculate those, and some basic descriptions of the equation, the meta features and learning equations, the volatility-targeted sizing cost equations, and the walk-forward equations. Next, we see on the screen, we have the trainer controls. We have start learning loop, stop training, and reset training history. Now, this is going to train based on the settings you have set here on the left. The first thing you can enter is tickers, and we have a long list of tickers here, and then you enter the start date. So it's going to pull all stock market data from this date forward to the present, and then it's going to iterate over that data, analyze, predict the next day, and then for each day, it's essentially going to predict the next day, decide if it was right, predict the next day, decide if it's right through the whole trading set, calculate how good it was at predicting what the overall average return would be if you started with $1,000 and some other values. And then at the end of it, it's just going to retrain the model and continuously retrain, getting smarter over time. You can upload custom data sets here if you want. If you don't upload it, it'll simply just pull it from open source like Yahoo Finance and others on the internet, so you don't have to. And then we have a few settings that you can tweak: the number of quantile states, the rolling train window, the number of days essentially, the round trip cost, the volatility target, the direction long and flat, or long and short. I'm doing long and flat for the first ones. You can enable the quantum inspired refinement and then set the values for what it's going to do there, as well as the training control parameters and optimize for Sharpe or CAGR, which is essentially year-over-year return. And then essentially search sensitivity, and then allow for shorting during search, even if the base is long and flat. So you have a lot of configuration values you can set here to refine both the backtest. And the backtest is essentially, it's going to simulate trades over the entire corpus of the data that it downloads from the date you specified and determine how accurate it was. It currently doesn't do next day predictions on the current price to the next day because I'm using this first iteration to essentially run the training and see how much smarter it can get over time. We'll show that in a second. So if you wanted to just do a simple back test and see what it could do for you, you can click that, or you can click Start Training Loop. And what it's going to do is it's going to literally just continuously train until you stop it. And it's going to put those training results in a table here. And essentially it's going to give you all the values for performance and the final equity you would have if you started with $1,000. You can see here that it's gone from 1317 to 2769, and it's only been through 6 iterations. Now, they do take quite a while to run because it's going over a very, very large data set, and it has a little progress bar here for each ticker, and you can see the best run equity curve over time. And so I'm letting the training run. What I really want to see is how it performs, over time, if I let it run for a week or two, and how much smarter it can get. And once I do that, once I see the results over probably about a week, I'm going to then make it predict next day prices based on the current price, based on its trained model, and simulate trades over a couple weeks to see how accurate it is to predict next day trades in real time against current values. And then once that's good and it's refined enough, then I'll implement auto trading features where it calls APIs and makes the trades for me with a $1,000 money pool, and see how it performs in a real world scenario. So that's really the demo, the overview of what's there right now. I mean, I've only worked on this for a few hours throughout my day before and after work. So I hope you enjoy it. We'll see how the training goes over the next week. I'll post another video at the end of the week about how the training went, and then I'll implement the next day prediction based on current price. We'll do another video, and then once that's good, I'll implement the auto trading feature where it trades against real prices with real money with a $1,000 pool. And I'll do a video on that, and I'll show you the iterative updates over time. And then when I'm done, I might release a shortened, less refined version. I don't want to give out all the secrets so that you guys can play with it and work on it and do whatever you want with it. So I'm really just about sharing. It was just a fun project that came about as I watched that video this morning. I just had to, get it out of my head, or it would have been the only thing I thought about literally the entire day. And I'll also do a video on kind of like how I built it so that you can know how you can do things like this too with very minimal effort, with a little work. And I really appreciate you watching the video. Thanks. Thank you for watching the demo. I hope you found this informative. In the future, I'm going to do a video on how I created it. And then in the future, I will also release it so that you can experiment. And remember, it's just a research tool. And in the future, when I release it, have fun experimenting, kids. Like, subscribe, comment, do whatever you want. Hope you liked it. Enjoy.
Brothers! What we doing live? Echoes in eternity.